Okay, explore number 6. What role do genetic drift, bottleneck effect, and the founder effect play in evolution? So, we're going to be talking about some other things that can drive evolution aside from natural selection. So, go ahead and draw out your template, date it, go ahead and put your reference. So we're in Living Earth, Unit 366, 3.6.6, and write down that essential question. What role do genetic drift, bottleneck effect, and the founder effect play in evolution? And tell me what you know or think. All right, well, hopefully you took a moment to do that. So let's start with Roman numeral 1. Populations can change by factors other than natural selection. Okay, these are due largely to random changes, and there's several different sort of things that we're going to talk about. The first one is gene flow. Okay, this has to do simply with genes coming into a population, what we would call immigration, and genes leaving a population, emigration, right? Um, could a population's allele frequency, the characteristics of that population change with the introduction of new genes, fresh genes, especially if they're different than what the population has? You betcha. That could affect it, right? Doesn't guarantee that it will affect it, but it can have an effect. It can drive change. And it can affect it by changing the population, or it can actually affect it by making it even more normalized. It can actually reinforce what's already there. The other possibility is when an individual leaves a population. And when it leaves, it is taken away its alleles with it. And if it carried alleles for a unique trait, those traits aren't going to be available when reproduction happens. And that could reduce the frequency of those alleles in that original population. So, those are two examples of gene flow that are due to immigration and emigration. There's another type that's called genetic drift, and this is the idea that genes they fluctuate. There's no such thing as a static, this is the way it is. Um, Sometimes there might be a few percent more of this allele. Sometimes there might be a few percent lower of that allele. And it just kind of bounces around that, what we call mean, that average. And in large populations, that may be negligible, meaning that it has very little effect. But if you're talking about a small population, that little bouncing around could actually affect it. It could actually for example, reduce an allele's frequency in the population and altogether eliminate that allele from the population. So that's something we see. It's called genetic drift. Um, there's two particular types of genetic drift that you often will read about. One is called the founder's effect, and the other one is called the bottleneck effect. The founder's effect is this idea that you have a population and then a small subgroup of that population leaves and they go and colonize somewhere else. So when they set up their new colony, whatever the alleles were in that new group, the new population as it grows may actually reflect that new group may reflect whatever alleles are present in the founders. And it may not exactly look the same as the original population that they came from. There's an example in South Africa with the Dutch. Some of the founders who went and colonized South Africa had alleles for Huntington's disease. And so, as the population grew in South Africa, the population of Dutch in South Africa had an unusually high percentage of the allele for this disease, Huntington's disease, higher than the original Dutch population itself. That's called the founder's effect. The another type that's similar to this is called bottleneck effect. And this is the idea that maybe in a population you have a catastrophe, it kills off most of the population, and whoever's surviving, well, their alleles are the ones that survive. So if they had an unusual percentage of alleles, then as they rebuild their population, that new population is going to reflect whatever alleles were in the survivor's gene pool. And it may not exactly look the same as what the original larger population was. And they give you an example of cheetahs who have very little DNA diversity right now. And they think that a catastrophe happened about 10,000 years ago by looking at DNA and molecular clocks. They're guesstimating that something really reduced the cheetah population a long time ago. And now what we have is the cheetah population that we do have has very low genetic diversity compared to the original population. And this is a result of being reduced to a small subgroup and then rebuilding just from that small subgroup's population, their gene pool. So in either one of these cases, you're looking at survivor groups that do not exactly look the same as the original population group from which they came. All right. Well, those are some of the examples. So go ahead and make sure you write yourself a summary paragraph. Make sure you take a look at Explore number 6. Okay. Take a look at some of the videos that they provide for you, and read any of the additional readings if you need to. All right. We'll talk to you soon.